This is another lecture about learning about electrical engineering. And this lecture is about the SI units related to electrical engineering. And also we will look into some of the important equations related to physics and electrical engineering in a basic form. So the first thing, this is also covered, some of the things have already been covered, and the first thing which I previously also said is that the electron is equal to 1.6 into 10 raised to minus 19 coulomb. So this is a basic element of any operation of any of the electrical engineering and or electrical circuits, etc. When you, even if you look into something like electrical circuits or magnetic circuits, etc., the flow of the current is essentially the flow of electrons, and this is what one electron is all about. And when you are saying that I am having 1 coulomb of charge, then you can take the reciprocal of this as 1.6 into 10 raised to minus 19 and electrons. This will give you the number of electrons which is needed for the producing 1 coulomb of charge, which comes up to close to 6.25 into 10 raised to 18 electrons. So these are the two basic things from where we start. And next, this the mathematical definition of current can be given as current is equal to, or the mathematical definition of charge can be given as charge is equal to current into time. So this is a mathematical definition of charge, and the mathematical definition of current is equal to charge divided by time, and the unit of current is ampere while the unit of charge is coulombs. So these are the two important units. Again, looking something into what force is all about. So force is given by mass into acceleration in mechanics, and the unit of force is Newton. And next, when you look into something like power, the power can be defined as work done divided by time. So work divided by time is equal to power, and the unit of power is joules, or the unit of power is watt. And when you're saying in terms of electrical, the power in electrical circuit can be given by VI, watts. So the voltage into current gives the power, which can be defined by a unit known as watts. Again, the resistance of the circuit can be given as R is equal to V by I, which is from the Ohm's law, which we saw in the previous lecture, and the unit of resistance is ohms. And V is equal to the electrical potential of the circuit at any point, and this is given by the unit of volts. So these were some of the important units, and if you are to see some more things, so what all we saw so far was I is, so again something like we saw power is equal to VI, and the unit was watts, and V is equal to potential of the circuit at any point if you are considering, then this unit is volts. E is equal to electromotive force or EMF. This is usually the voltage of a source, and this can be given by the unit of volts. And the next, after seeing the power, the next thing to say is the energy. The energy of the circuit can be given as power into time, and this can be given as VIT, and the unit is joules. And again, when you are talking about energy, it's also given in terms of kilowatt hour. This is the usually the energy consumed in a circuit. So 1 kilowatt hour is usually equal to 1000 watt hours. So these were some of the basic terms and equations of electrical engineering defined mathematically. And if you say about the SI unit or the standard units, standard international units of electrical engineering, then you can say that if you are having length, then the unit of length is meter, and the unit symbol will be M, and there is time, the unit of time is second, and the symbol is S. If you are having current, electrical current, the unit is ampere, and the symbol is A. And if you are having the quantity symbol, this can be L in this case, this is time in this case, and this is I in this case. And the resistance R, the unit is ohm, and the unit symbol is R or ohm, and the quantity symbol is R. Then you have the potential difference, the unit is volt, the symbol is V, and the unit quantity symbol is also V. And the work, the symbol is the unit is joule, can be given as J, and the quantity symbol is W. For power, it's P, the power is watt, and the quantity symbol is, or the unit is W, and the quantity symbol is P. So these are some of the important SI units when you're talking about electrical engineering or physics related to electricity. But there could be more units, but I have highlighted something like 1, 2, 3, 4, 5, 6, 7 important units which you could come across on a day-to-day usage basis. So whenever you are dealing or solving with any problems, so it could be expected that you are converting the answer by taking the SI into the SI system. So one simple case which I could explain here is, suppose you are having a current of 10 ampere, and your time for during which the current is acting on a circuit is 2 minutes, and this is a question, and the task is to find the charge flowing through the circuit, passing through the circuit for the period of 2. So the equation of the charge is IT, and the unit is coulombs. So you'll have to convert this in such a way that this is the SI unit of charge, and again the ampere is the SI unit of current. But again the minute is not the SI unit. Minute is not the SI unit of time. The SI unit of time is seconds. So you'll need to convert this into seconds. So 1 minute is equal to 60 seconds. So you will need to multiply this whole thing in seconds. So it's 10 into 2 into 60 ampere seconds. So in this way you will get something like 1200 ampere seconds, which is equal to coulomb. So if you are having any circuit any problem, so it is assumed that you are, unless it is specified, it is assumed that you are solving the circuit in the problem in such a way that you are getting the answer in the SI units.